Hello, we're back with Chapter 4. This is Lecture 3. We're going to put the consumer surplus and producer surplus together and talk about our total surplus, which is the gains from trade. And one of the main goals in microeconomics is to maximize the gains from trade, which is to maximize the total surplus. Total surplus is equal to the consumer surplus, CS, which we use down here, plus the producer surplus. We use PS for that, which is right there. And again, your consumer surplus is your willingness to pay minus the price, and this is the difference between the most someone is willing to pay, which is the willingness to pay, minus the price, which is the price that you do pay. And the producer surplus is they take the price, they like the price because that's what they get from consumers, and they subtract from that their cost, which is measured by the willingness to sell, which is the least amount they're willing to sell it, and that's a measurement of their marginal cost. So let's go ahead and take the same consumers here. Oh, by the way, in the first lecture, when I talked about consumer surplus, I had Mia here and Mia down there, but the second table I had Hugo down there. That was a mistake. It didn't matter because we weren't buying down here anyway. But nonetheless, there was a mistake there, which I'm sure a lot of you noticed. So here, let's again recreate our tables over here, and this is now WTP. I just realized I should add WTS as well. Both are going to be measured there. And we can start with the cost over here because they're lower down here. And so again, we have Jax, who's willing to sell the first cake at $2. And so that's $2 there. And so we're going to measure these again by bars. Let's move this up. And so is Jack's marginal cost, and then Amir is going to be up here. And then we have Tessa is going to willing to sell at $6, the lowest price she's willing to sell at, which measures her marginal cost. Right there. And again, the difference why we have different marginal costs is probably due to the differences in their opportunity cost of their time. And then we have the fourth one, which is Vera, and that's $10, which would be about here. And then we have Milo at $12. And then Hugo at $18. And then Jade at $20. And these are our marginal cost, and they're rising because we rank them from lowest cost to highest cost. Now let's go over and do the same thing for the buyers. We have Mia there is going to pay $20. That's way up there. And then we have Noah at $18. And then we have Ruby at 12. And then we have Mark at 10, which is already there, right there. And then we have Mia again Sarah at 8. It'll be about there. And then we have Mia again at $6. Right there. And then we have Luca at $4 right there. So these ones here coming down are your margin utilities, and that measures our demand, and these going up are your marginal cost. So this is the marginal cost of the first one, marginal cost of the second one, third one, marginal cost of the fourth one, marginal cost of the fifth one, marginal cost of the sixth one, marginal cost of the seventh one. This is the margin utility of the first one from Mia, margin utility of the second one from Noah, Marginal utility of the third one from Ruby, and Mark's right here. Marginal utility of the fourth one, which is the same as the marginal cost. And then down here is the marginal utility of the fifth one, marginal utility of the sixth one, marginal utility of the seventh one. Now we can see why I was using the price of $10 in the prior lectures, and that's because that's equal. If this is supply, upward sloping, and that's demand, they intersect right at 4. And that's where the marginal utility is equal to the marginal cost, and that's right here with Mark buying the fourth one at $10, and Vera is just willing to sell the fourth one at $10. And so $10 becomes the equilibrium price. It's the only price on both tables where we have the same quantities. We have 4 cakes being produced here, we have 4 cakes being consumed here, and so the quantity demanded here is equal to the quantity supplied here. You can see that if the price were, say, $20, that's not equilibrium, because at $20 only Mia would buy a cake, where all 7 of our producers would bake cakes. So the quantity supplied would be 7, the quantity demanded would be 1, we would have a huge surplus, and so the price would have to come down. If, say, the price were at, say, $4, then all 7 consumers would want to buy cakes, even Luca, just barely, while only 2 cakes would be produced from Jackson and Amir, and we would have a huge shortage, and the price would go up. So the price would settle down at $10, which is efficient, as we'll find out right now when we look at the surpluses. So this is the margin utility we get from consuming that first cake, which goes to Mia, where the marginal cost of producing it is down here. And so that cake is quite valuable to produce. It's going to bring in $20 worth of benefit, and it's only going to cost $2 worth of resources. And so that would have a net gain to society of $18. We're taking $2 of resources to produce something that has a value of $20. So down here, we can actually keep a running total of total surplus. There's actually 2 ways to do it. I just talked about one way, which is margin utility minus marginal cost. It's $20 minus $2, which gives us $18 of total surplus gains from trade. We can also measure it by the producer's surplus. Now the price is $10, so that's going to divide where the gains go. Mia doesn't get all $18 of net gain, because even though the cost of baking the cake was only $2, the price was $10. And so Mia does not get all $18. Mia's share would be 20 minus 10, which would be $10. 20 minus 10 is equal to $10. And then the producer's surplus would be the $10 that the seller gets, Jax gets, minus the $2 cost of baking the cake, and so Jax gets $8. And so together it would be $8 of producer surplus plus $10 of consumer surplus to get the same $18 of total surplus gains in trade. Is the second cake efficient to produce? And the answer is, if it has a positive social surplus, and the answer is going to be yes. And so again, the price $10 again goes out to here. And we had a total benefit utility that goes to Noah for buying that second cake. And so Noah's willing to pay $18, and it only costs $4 to produce it. So we're going to take $4 worth of resources, which would be flour, eggs, and Amir's time, to produce that second cake, and it's going to get a benefit that goes into Noah, essentially physically into Noah as he eats the cake, of $18. And so we have $18 of utility, $4 of cost, has a net return of $14. Now all $14 doesn't go to Noah. Noah has $18 willingness to pay, has to pay $10, so Noah's share of the $14 is $8. And then Amir gets $10 from Noah, uses $4 up of resources, and so Amir's share of the surplus, total surplus, is $6. And so down here you would take Amir's $6 plus you would take Noah's $8, and that gives us the same $14. And the $14 is right here physically between that bar and this bar. You can see as we consume more cakes, the total surplus is going to be going down because, again, we started with the cake that had the most value and the cake that had the lowest cost to produce. And then we go to the second most valuable cake and the second least costly one to make, and so on. And as we move down the consumption side, the margin utilities will be falling, and we move up the supply side, the marginal cost will be rising. Looks like I've gone far enough for this lecture. What I'll do is I'll break it up into two parts, and so this will be part one.